Good afternoon, and thanks for having me here today. And Marie Haga just gave us a wonderful, compelling preview of crop diversity and the importance of preserving crop diversity. And she gave us the specific example of grass pea, Lathyrus sativa, and a brief introduction about coffee. So I'm going to give you more details about coffee and preserving coffee's genetic resources. So there are numerous papers that talk about how impoverished of genetic diversity the cultivated coffee is. And there are numerous papers that also say the importance and urgency of conserving coffee's genetic diversity. So what is genetic diversity and why is it important? Genetic diversity is the extent of genetic variation within genetic variation. It could be within a species or it could be across species. So if you look at coffee itself, the genus Coffea is highly diverse in species. It has 125 species distributed in Africa, Madagascar, Mauritius, Comoros and Reunion Islands, South and Southeast Asia, and Australia. And all these 125 species occupy various types of environments. And taking Madagascar as an example, Madagascar has 59 species of Coffea. And all these species occupy varied habitats from the dry forests of western Madagascar to the eastern rainforest. And by occupying these different ecological conditions, what it does is the coffee species develop adaptations for survival in these specific habitats. And when you look at the cultivated coffee, though, cultivated coffee is lacking in genetic diversity. And the reason the cultivated coffee is low in genetic diversity is because of the way it originated and the way it was distributed around the world and how it was domesticated. And genetic diversity is, the genetic diversity, the greater the genetic diversity, the greater are the chances of survival of species for the long term. But when you look at coffee in the wild, cultivated coffee, compared to cultivated coffee in cultivation, the wild coffee in Ethiopia, as well as in gene banks, have much more genetic diversity. And so we need to look at the coffee in the wild and also in gene banks. So a gene bank is a place where we can store genetic diversity, and we call them genetic resources or genetic material. And for coffee, as it was mentioned earlier, they cannot be stored as seeds for the long term. And so the way we conserve these coffee is in field collections, in field gene banks. And a field gene bank, the maintenance of a field gene banks involve all the inputs and care that would go into cultivating a crop. And with that, there are a lot of risks and risk associated with cultivating crops in fields, and which results in loss of plants. And every time a plant dies, there goes the diversity, the genetic data that is contained within that plant. So realizing the urgency of this loss of genetic diversity, the Global Crop Trust and World Coffee Research came together in 2016 to develop the Global Coffee Conservation Strategy. And the goal of the strategy is to conserve coffee for the future. So to really understand what the Global Conservation Strategy is, we need to understand what are the challenges in conserving coffee genetic resources. So conservation of coffee, general genetic resources happens in two ways. One is in situ. There is in its natural habitat, such as the wild coffee forest in Ethiopia, or ex situ, which is outside of the natural habitat, such as in a gene bank. And in situ conservation is a much more dynamic process where the plants are able to evolve in the natural habitat. But along with it also goes the threats of human and induced as well as natural threats, which could wipe out an entire collection. So, and also it is very hard for researchers to access this genetic material. So I'm going to give you an example in Madagascar. So my research work has involved studying the genetic diversity of wild species in Madagascar. And one of the species I was studying was the Coffea vatawaviensis, endemic to the Kianjawato eastern rainforests of Madagascar. So during my visit in 2008, I was looking for this plant near the forest near Kianjawato in Fianaritsu district. I was specifically looking for this species in this location because there is the National Museum of Natural History in Paris, France, has a specimen that was collected in this location back in 1962. And I wanted to see if I could find it again. So our team went to the village of Ansanavolo, which was the closest village to go to the Ansanavolo forest. And in talking to the local villagers there, we found out that these forests have been long gone. So that is now all there is proof of this species is a dried herbarium specimen in a herbarium in France. And that is diversity lost forever. And so there are so many human-induced pressures in Madagascar and many countries that have led to deforestation and land degradation. And this is in Madagascar. And so in comparison, ex situ conservation is where we collect the plants and transfer them into an external site, such as a field gene bank. And coffee, as we know, we cannot conserve as seeds, so coffee, the only way we can conserve ex situ is in field gene banks. And so as part of the strategy, as we were developing the strategy, we did surveys and site visits to key gene banks of coffee. And some of the key findings of our site visits and survey was that many of these gene banks, many of the plants in these gene banks are extremely vulnerable. And many of the trees are getting old. Many of the trees are old, and the aging, these gene banks, many of them were established in the 1960s and 70s. And so most of the trees are about 40 to 50 years old. And the age of the plants impact the productivity of flowers, pollen, and seeds. And also, they're more prone to pests and diseases. And also they're not in the wrong place. A lot of the gene banks are located in places that are not ideal for growing coffee. And the perfect example is the Cartier Gene Bank in Costa Rica. And this gene bank is very important because this is the only international collection of coffee. And also, a lot of the trees, because you have so many different types of trees, there are common Arabica and there are wild species and all of different ages, they all need different types of care, and these gene banks do not have the resources to give the care that they need. And also, they are all exposed to various external forces, such as vandalism, as a mining activity that is happening in Madagascar, the Fofifa gene bank right now, as well as natural catastrophes, and another example in Madagascar where an entire collection was lost due to a cyclone. And also, we have, all these gene banks are at the mercy of complicated bureaucracies, and which leads to lack of funds and resources. And yet another example in Madagascar, where they do not even have funds to replace this broken bridge. And also there are lack of political will, land tenure issues, where with development happening around the gene banks, the government could decide to allocate the land currently held as Coffee Gene Bank for development, and as well as there is also lack of trained staff. So, the coffee gene banks are facing so many different challenges. And so a lot of the gene banks are functioning due to the passion and commitment of individual curators who actually literally have put in their blood, sweat, and tears into keeping these gene banks functioning. And a great example is a dear friend of mine, Dr. Jean-Jacques Rakoto-Malala. And without Jean-Jacques' commitment and passion, the gene bank the Fofifa gene bank in Madagascar will not be in existence today. Established in 1954, the Fofifa's Kianjawato Coffee Research Station has seen many ups and downs. And for almost 2 decades, between 1982 and 2002, government funding for that research station completely stopped. And many trees in the collections died during that time. But Jean-Jacques kept this gene bank going with minimal care. with about 76% of, today it really runs on a very on a shoestring budget. Like as you saw, they do not even have funds to repair the broken bridge. And with 76% of the Madagascan coffee species under some form of threat in the wild, it could eventually, in the next decade or so, the coffee collections maintained in the FOFIFA gene bank might be the only representatives of these species. And so we cannot take that chance. So we need to act now. And if we lost these genetic resources, what we are losing is any possibility of specific genes that could confer traits such as disease resistance or a drought tolerance, or even with Madagascan coffee, the caffeine-free characteristic. And so there are all these genetic resources. They have the potential to be used in breeding programs. And by knowing the genetic diversity and the specific trait of a species, they are being used in breeding programs. Both Brazil and Colombia has been using their own coffee genetic resources for breeding improved varieties that they have been distributing to their farmers for cultivation. And a great example of the use of genetic resources is none other than the story of Geisha, the beloved variety that is known for its exquisite flavor profile. And actually the story, what many of you may not know, is the story of Geisha is actually a story about genetic resources and gene bank conservation. And hadn't it been for the Coffea gene bank in Costa Rica, the Geisha would not have taken root in Hacienda La Esmeralda, the Panamanian farm that made it famous. And British consul Richard Worley in the 1930s led an expedition to Ethiopia to collect coffee plants to send along to Kenya and Tanzania. Among the plants he collected, one was Geisha. And in the 1950s, the Food and Agriculture Organization of the United Nations collected seeds from the geisha that was cultivated in Tanzania, known as VC 496, and sent them to Costa Rica. And in the 1960s, the Panamanian government collected plants from the Coffea gene bank and brought them back to Panama. Of the 3 or 4 varieties that they brought back, one was Geisha. And the Geisha was distributed to farms in Panama, and one of the lucky recipients was Hacienda La Esmeralda. But then it took a while for us to realize the power of this variety. And so the Geisha story is really, it illuminates why gene banks matter. And had it not been, the Geisha variety was in plain sight for about 80 years. But it took a while for us to actually knead the flavor. In 1930, when it was collected from Ethiopia, the super specialty coffee industry was not in existence. So it needed a system to be in place to preserve it, to protect it, and to care for it before its actual traits were needed. So imagine there is a plant in the coffee forest in Madagascar that has the capacity for resistance to a disease that we don't yet know exists, but could wipe out the entire cultivated coffee off the face of this planet. If that coffee is gone, so is the coffee industry. So these are just some examples of cultivated coffee, but researchers have also turned to other species in breeding programs. And a few examples include Coffea zanzibariae from Kenya and Tanzania, as well as some of the Madagascan coffee species have been used for caffeine-free breeding. And imagine if we can create a naturally caffeine-free coffee that would not have to go through the harsh decaffeination process. And let's think about climate change. Coffea stenophila from Cote d'Ivoire, it's a variety that is a species that is adapted to all sorts of climates. And they can grow in dry areas, wet areas, in forested lands. So if we could identify the genetic mechanism that confers this trait to this genetic flexibility, then we could exploit them in breeding. And another drought-adapted species is Coffea racemosa. So So these are just a few examples of species and varieties that we have used in breeding. And as Hannah mentioned before, I would encourage all of you to go to the sensory experience room and taste the 3 Heifer hybrids that we have developed from Arabica coffees that came from the Cartier Gene Bank collection. That is a great way to explore coffee diversity through taste. And so not only do we, so we have all these species that we know with known traits, but there is so much more untapped potential in these gene banks that we don't even know about. And the biggest challenge with coffee is there is no accessible database for coffee collections. So we do not know what is out there. So accessible information is critical to use. And so we know that we have a problem, and so we need, it's crystal clear, we need a system set up for coffee to conserve it and to make it more accessible. And that is what, as Marie explained before us, no agricultural industry in the world can afford to ignore this problem. And coffee is no different. And all the work that you all do is dependent on the plant. And that is why the Crop Trust and World Coffee Research is developing this strategy. And the strategy is actually a framework to bring stakeholders at all levels, local, regional, national, and global, to build collaboration and partnership, so that way we can protect the genetic diversity as well as make use of them. And as Maurice said, it is not enough that we conserve this diversity, we also need to use them. And that is where the benefit comes from. So the strategy actually, and so what we want to do is protect the crop for the future, as well as the livelihoods that depend on these crops. So the strategy identifies 6 key high priority action items. And so the first thing is we have identified 4 major origin collections, and the origin collections are those where coffee grows wild in their natural forests, such as Ethiopia, Cote d'Ivoire, Madagascar, as well as Cartier due to the international status of that collection. And so to secure the genetic resources that they hold, we need to find stable funding and self-sustaining funding, which will be through the Crop Trust Endowment Fund. And then these 4 gene banks need to upgrade the facilities and have to build capacity for routine operations. And also, as a part of the sharing, there need to be some benefit associated with the sharing. So we need to develop a legal framework where we can develop a legal framework for sharing and use of these genetic resources. And also, as I said before, there is not an accessible database for coffee collections, and we do not know who has what. And so the first, one of the priorities would be to develop an accessible database which will link the origin collections with the user collections, the users being countries like Brazil and Colombia who are using these collections for breeding programs to develop improved varieties. And then the safety duplication is key because so we need to look at other complementary strategies like cryopreservation, which is the storage of seeds and tissue at -196 degrees Celsius in liquid nitrogen, as well as we need to make sure that we are backing up these collections in at least one other location with conducive climate conditions, so that way what happened in Madagascar, an entire collection was lost due to cyclone, does not happen again. And also we need to look at in situ conservation, because in a lot of the countries where these species grow, they may be, if they were to be gone in the wild, the only representatives would be in the gene banks, and these gene banks are in a position to engage in reforestation efforts and to get to protect these species. So the strategy, these are the 6 high priority action items. So the strategy, obviously it is important to have the strategy, but we are not done yet, because we still have to execute the strategy. And for that, the biggest work we'll have to do is get commitment from all these countries that they would support and preserve those gene banks and continue to preserve them and to share those genetic resources. So for that, we have to raise the money to help them do that. And so there is a role for all of you in this, and there's a role for the industry to make sure that this happens. In the end, if the coffee production declines and the coffee plants are lost, it is the entire coffee industry that is going to suffer. So as Peter said earlier when he opened the symposium, he talked about risk and reward. And the risk is that we could lose these genetic resources, but we do have the strategy now. So there is a reward in making sure that we implement these strategies, because the future of our coffee industry depends on preserving these genetic resources. And it's all about collaboration. I think Rick mentioned about collaboration. And the collaboration needs to happen at all levels along the supply chain. Thank you.